Ladies and gentlemen, welcome to today's lectures. Before I proceed to today's lectures, let us recap what we have learned in the previous lectures. In the previous lectures, we've discussed 4 disciplines related to spatial data science. That is GIS, Spatial Database Management System, Big Data System, and Data Analytics, and open source software for each discipline. So we discussed about the open source software for each discipline, where we talk about what is open source software and other related issues. If you've not watched this video, kindly look at the description part of this video to have access to a link to watch it, and also kindly subscribe to my YouTube channel to support me to grow. So today's lecture, let me give you an outline of this presentation. The outline of this presentation will include introduction of spatial big data, its definition, and the examples. In the end, I will give you a brief overview of the value of spatial big data. In other words, what we can do better with spatial big data than with only spatial data. Let me kindly give you a little background on spatial data. It is important to know that more than 80% of all information in society has spatial reference. Spatial data is data with a direct or an indirect geographic reference to the surface of the earth. Spatial data is an indispensable part of basic infrastructure of every country, as are roads, hospitals, and schools. Spatial data is strategically important to decision makers at all levels. Spatial data is information that describes objects, events, or other features with a location on or near the surface of the earth. Geospatial data typically combines location information, usually coordinates on the earth, and attribute information, the characteristics of the object, events, or phenomena concerned, with temporal information, the time or lifespan at which the location and attributes exist. The location provided may be static in short term. For example, the location of a piece of equipment, an earthquake event, children living in poverty, or dynamic, for example, moving vehicle or pedestrian, the spread of an infectious disease. They generally accompany attribute data, which describe name, condition, and other information. Spatial data is also known as geospatial data, or geodata, or GIS data. Geospatial data typically involves large sets of spatial data gleaned from many diverse sources in varying formats and can include information such as census data, satellite imagery, weather data, cell phone data, drone images, and social media data. There are uncountable spatial data examples as mentioned above. Let me also give you more examples such as parcel boundary, road network, river network, land use, land cover data, digital elevation model, which depicts the surface of the earth, orthophotos, which are photos as well as maps, some 3D maps, which are recently available in many applications. Geospatial data is most useful when it can be discovered, shared, analyzed, and used in combination with traditional business data. Spatial data is represented by 2 data models. These are vector data model and spatial data model. Now let us discuss about spatial big data. Spatial big data can be defined as spatial data with big data characteristics, or opposite way around: big data with spatial context. Spatial big data exceeds the capacity of commonly used spatial computing systems due to volume, variety, and velocity. Spatial big data comes from many different sources, such as satellites. These are quite a few satellite imaging systems which generate a homogeneous size of spatial data every day. For example, LARSA 7 system can theoretically downlink 17 terabyte of satellite image data per hour. Drones, vehicles, that's vehicle trajectory, which is well known spatial big data. For example, taxi trajectory in Accra city, card transaction data with locations such as credit card and public transit card. Geosocial networking services, mobile devices, cameras, a collection of sensor data with location also produce spatial big data. Some types of spatial big data are peed every minute for every road segment. GPS trace data from cell phones, engine measurements of fuel consumption can be estimated from fuel levels, distance traveled, and engine idling from engine RPM and greenhouse gas emissions. Some of the challenges of spatial big data are listed as retaining computational efficiency, storing spatial big data into cloud and applying new data when spatial big data or change old data. Now you are looking at a list of application fields. They are eco-routing for minimization of fuel consumption, urban traffic analysis for optimization of transportation service, real-time city operation for disaster response and mitigation, geosegmentation for marketing with floating population data. Other examples are spatial business intelligence and geopolitical analysis with geotagged SNS data. They are good examples. For natural science, climate change study with satellite image analysis will be a good example of spatial big data. Another example I have is the healthcare application. In this lecture, you studied on spatial data and spatial big data as input material for spatial data science. I believe spatial data science gains more and more importance and significance in many application fields after we have spatial big data available, which can present better insight as well as more accurate analysis. This is the end of the video, in which we have discussed related disciplines to spatial data science, software, solution framework, and datasets. Hopefully, you have enjoyed it. In the next video, we will discuss each discipline of spatial data science in more detail. See you then. Before you go, kindly subscribe to my YouTube channel to support me to grow. Thank you.